high air pressure and low air pressure. Air is all around us. It is difficult to tell since it has no color and no smell, but air varies in temperature and humidity. A large body of air with the same temperature and humidity throughout is called an air mass. The temperature of an air mass depends on its north-south location with respect to the equator, also known as its position of latitude. Air masses at low latitudes are close to the equator and are therefore warm or hot, and air masses at higher latitudes are cold. Also, air masses that form out at sea suck up moisture from the water, making the air humid. Over continents, air masses are dry. Now, let's find out more about the 4 air masses that affect Korea, a country located in Asia. The first is the Siberian Express, an air mass that originates in Siberia. Even the name sounds cold, doesn't it? The Siberian Express influences the weather in Korea in the winter, making it cold and dry. The second air mass that affects Korea is the Northern Pacific High. This air mass forms over the ocean at latitudes lower than Japan and is hot and humid. This air mass usually affects Korea in the summer and is what causes our rainy season and hot summers. Third, we have the Okhotsk High. It is cold but humid and forms over the Sea of Okhotsk, which remains cold until May or even June. In late spring to early summer, before the heat waves begin, the Okhotsk High expands out over the East Sea. It then blows to the west over the Taebaek Mountains, creating what is known as the Foehn effect, a dry, warm wind that blows down the slope of mountains and affects local winds. Lastly, there is the Yangtze River air mass. It originates in the low latitudes of mainland China, making it warm and dry. It affects Korea in the spring and the fall and is the cause of yellow dust and cold spells in late spring. The boundary where 2 air masses with different properties meet is called a frontal surface, and the boundary where a frontal surface meets the ground is called a front. In simpler terms, a front is the line where cold air or hot air meets the surface of the ground. Fronts can be divided into cold fronts and warm fronts, depending on how the cold air and warm air meet. When a front passes through an area, weather changes occur on either side of the front. When a cold front passes over land, air temperatures drop, air pressure rises. Behind a cold front, cumulus clouds form, resulting in showers concentrated over a small area. When a warm front passes over land, air temperatures rise, the air pressure drops, and stratus clouds form, with light sprinkles of rain over a broad area. There are also occluded fronts and stationary fronts. Cold fronts move quickly, while warm fronts move slowly. When a cold front and a warm front are moving in the same direction, the faster cold front catches up to the warm front, and a new front forms where the 2 fronts overlap. This is called an occluded front. A stationary front occurs when neither of the 2 air masses is strong enough to push the other one out of the way. This type of front does not move very much and stays in the same place for a long time. If there are torrential rains at the front, then the front is called a rain front. This is an example of a weather map that we see on the news every morning. On this weather map, points where the air pressure is the same have been connected by a line, which is called an isobaric line. Places with higher air pressure than the surrounding areas are marked high, H, and areas of low pressure are marked low, L. The movement of air from high pressure to low pressure is called wind. The direction and characteristics of the wind that blows in areas of low pressure and high pressure are different. Around low pressure areas, rising air currents form, and around high air pressure areas, falling air currents form. In low pressure areas, moisture-laden air rises up and forms clouds, resulting in cloudy, rainy, or snowy weather. And around high air pressure areas, the air descends, making it difficult for clouds to form. This results in clear weather. High pressure zones are divided into stationary high pressure zones, which remain in one place with very little movement, and migratory high pressure zones, which separate from the stationary high pressure zones and move with westerly winds. The Siberian high pressure zone, which affects Korea in the winter, and the North Pacific high pressure zone, which affects Korea in the summer, are both stationary high pressure zones. Meanwhile, low pressure zones can be divided into temperate low pressure zones and tropical low pressure zones, depending on where they occur. Temperate low pressure zones occur at cold fronts around 60 degrees latitude. First, cold air and warm air meet to form a stationary front. Temperature differences between the air causes ripples, and the rotation of the Earth causes the low-pressure systems to move in a counterclockwise direction. Cold fronts and warm fronts form at the center of the low-pressure zone. First, ahead of a warm front, stratus clouds form, with light sprinkles of rain over a broad area. Between a cold front and a warm front, there are almost no clouds, resulting in clear weather and hot air temperatures. Behind a cold front, cumulus clouds form, resulting in showers concentrated over a small area. Temperate low-pressure zones ride westerly winds and move from west to east. This is why a person located to the right of a temperate low-pressure zone is able to view weather patterns preceding a warm front, between different fronts, and behind cold fronts. Lastly, the cold fronts move faster than the warm fronts, causing the fronts to overlap and form occluded fronts. As the warm air rises above the cold air and stabilizes, the temperature low pressure zone disappears. It takes around 5 to 7 days for a temperate low pressure zone to disappear. Next, we have tropical depressions. These have different names depending on where they occur. In Korea and Southeast Asia, tropical depressions are called typhoons. Around the Atlantic, they are called hurricanes. In other places, a tropical depression is known as a cyclone or even Willy Willy. Generally, a typhoon is a tropical depression, where the maximum wind speed near the center is 17 meters per second or greater. The diameter of a typhoon can vary from 200 kilometers to 1,500 kilometers, and the average height of a typhoon is around 15 kilometers. Typhoons originate over tropical seas using the heat released when water vapor condenses. The stronger a typhoon, the lower its central air pressure. Typhoons start out by moving in a northwesterly direction following the trade winds. They change direction when they meet the westerly winds at 25 to 30 degrees latitude and move toward the northeast. The point where a typhoon changes its course is called a typhoon's turning point. So then, how do typhoons die out? Most typhoons originate over tropical seas and move north. At high latitudes, the temperature of the ocean water drops. When a typhoon makes landfall, it loses its supply of water vapor, and friction with the ground causes a lot of kinetic energy, which weakens the storm. When the typhoon weakens, the pressure at its center rises, causing the typhoon to die out. Intense typhoons cause sea levels to rise, and this is called a typhoon surge. The sea level rises due to the low air pressure and winds of the typhoon. More specifically, the sea level rises 1 centimeter for every 1 hectopascal decrease in air pressure. A typhoon surge is when the sea level below a low air pressure zone rises by around 50 centimeters. These typhoon surges cause even more damage when they occur at high